All right, folks, we are going to be starting a new chapter. Chapter 6 continues our adventures in trig. So we are going to go on to 6.1, which is angles and radian measure. And I am going to waste no time getting over to our notebook. This is going to be somewhat review some new stuff, a little bit of everything. It's basically just getting familiar with two things to start. We're going to look at going from a degree measure. I don't know why I wrote that. Going from degree measure to radian measure, and also converting, let's fix that, from radian measure to degree measure. So going back and forth between these two, and not just with our standard nice unit circle values, but any value. So what they're going to ask you is things like this. They're going to say, change, for example, change each radian measure, or let's start with degrees. You're more familiar. Change each degree measure to radians. All right, and how do we do that? They'll give you something like, let's say 36 degrees. All right, if you have 36 degrees and you want to change that into radian measure, well, we need a conversion factor. You know, dimensional analysis, you know how to change things. You use some kind of a conversion factor. Well, the easiest one to deal with is we know pi is equal to 180 degrees. So just like in dimensional analysis, I drew this little grid because if you remember this, you probably saw this either in your earlier math class or most likely your science classes where your first time you had to do some changing of measures. When you do that, we know that our conversion factor is pi is equal to 180 degrees. So what we do is we use this equivalence in this ratio. So what we're going to do is we want to cancel our measures. So degrees are considered on top when we start out. So I'm going to put 180 degrees on the bottom here and then pi on top. So we have our new measure of radians on top and our degrees on the bottom. This way, it's not truly this, but it's kind of the idea that the degrees cancel. So when I multiply this out, I would get 36 pi over 180. Now, we don't leave it that way. We've got to get that down further. So 36 goes into 185 times, right? So this is pi over 5. And that would be, whoops, I missed. That is our solution to this, fully reduced fractional measure of radians. All right, so 1/5 pi. Again, not one of our nice ones that's on the unit circle that we know the exact values for, just being able to change between them. So let's do another one. Let's do negative 250 degrees. Again, if I start out with the same setup, I'm going to go to 180 degrees on the bottom. I'm going to go pi on top. And when we multiply this out, we get negative 250 pi over 180. Well, we know, let's see, do this. We know it's negative 25 pi over 18. I don't think there's anything else that goes into that besides 10, right? 5 and 5 and 3 and 6, 3, 2, 3. Nope, nothing else. So there we are. All right, so pretty straightforward. We're using that conversion. Now, what about going the other direction? What if it says, instead, for example, it says change each radian measure to degrees. All right, if we have to do that, well, now, move this out of my way here. All right, if they give us, let's see, let's do something basic. 2 pi. All right, well, 2 pi, again, this one is one we might know, but just let's say just assume, I guess, for a second that we don't know it. So again, I'm going to use that idea that pi is equal to 180 degrees. So this time pi will go on the bottom, 180 degrees would go on top, the radians cancel, and it gives us 360 degrees. We knew that, didn't we? 2 pi is 360 degrees, but I just wanted to start with a basic one. So let's do something a little more involved. Let's do 3 pi over 16. Let's change that into degree measure. So again, I'm just going to do this. I'm going to put pi on the bottom, 180 degrees on top. And when we look at what we can do here, I can cancel the pi's. In here, what can I do? I can cancel 4. I think I can cancel, well, 16 goes, does 16 go into that? No. Nope. So, well, let's just do this. 3 times 180 is 540 degrees over 16. And what is 540 over 16? They want this to the nearest tenth in your book. So let's find out what that comes out to. Let's see, round to the nearest tenth if necessary. This is only for the degrees. So this comes out to 33.75 degrees. All right, let's do another one. Last one of these. Let's do 13 pi over 30. Changing this to degree measure, we do the 180 over pi. And so we get 13 times 180. And that's 2340 over 30. So divide that by 30 and you get an even 78 degrees. All right, so again, just using this idea that pi equals 180. And you just have to know how dimensional analysis works to know whether you do 180 over pi, or like in the previous example, you do pi over 180. All right, again, not something to memorize, just know your dimensional analysis and you'll know which direction it has to go. All right, we are going to do some, in this section, they are going to ask you to do some exact values of trig functions again using our reference angle ideas and things like that, the unit circle values. So they're going to ask you to do that. I'm not going to spend any more time on that in this, as we've just spent 2 videos on that. But we are going to go to one other thing. And this is the idea that we want to be able to find the measure of an intercepted arc. Now, what is an intercepted arc? Well, we're talking about the intercepted arc of a circle. All right, so what that's going to look like. Let's draw a circle. All right, if we draw a circle here and we talk about its intercepted arc, well, let's go back. If we have a center here and we draw any arc in here, or I should say any angle in here. All right, if we have this angle, we know if this is our center, that these are radii, right? And what we want to be able to find out is the length of this arc. This is the arc that we call intercepted arc, all right? It's the arc that this angle, what we call subtends. You may see that word. This is a subtended arc. All right. It's when we have a central angle, an angle whose vertex is at the center, we can find the length of this intercepted arc, right? And this is where that idea that I told you about with unit circle, where the fact that our radian values have a relationship to length allows us to do this. Now, the formula for this, we call this length S, all right? And S, I think they called it that because it's the subtended arc, but its length S is equal to R theta. So if we know this theta and we know the radius, we can find the length of that arc. So for example, they may tell you, given a central angle of 147 degrees, find the length of its intercepted arc in a circle of radius, let's say 10 centimeters. All right, so how do I approach this? Well, first off, remember what I said in the beginning is got to be key in your mind. I said when we talked about the length of this arc in a unit circle, I talked about the fact that we needed radians in order to find lengths from angles. All right, we can't use degrees. They gave us a degree measure. So the first thing we got to do if we're going to use S equals R theta is we've got to change our theta. Our theta right now is 147 degrees. We can't use that. So we have to change that into radians. So we use the previous skill. I'm going to say that I have 180 degrees down here and I have pi here. And let's find out what our measure is there. All right. So honestly, what I would do is leave this as 147 pi over 180 and just call that our theta. All right. Because then I don't have to worry about reducing this anytime early. So what I'm going to do is just leave it like that. And I'm going to say S is equal to R, which is our 10 centimeters, times our theta, which is 147 over pi, or 147 pi over 180. Sorry. And the degrees have canceled, right? And we think of this as 10 over 1. So this is 1470 pi over 180. We don't want it that way. They're going to want this to the nearest tenth. So let's see what that is. That comes out to be 25.6563. So let's just call that 25 point, what would that be? To the nearest tenth, it would be 0.7. And that is in centimeters. That is the length of that arc. All right, let's do another one. Given a central angle, if they tell you that, let's say theta equals 3 pi over 5, and we have a radius equal to 12 feet, what is the length of the intercepted arc? So we have our theta in the right terms. So our S is going to equal 12 times 3 pi over 5. So we can think of that as 36 pi, pi over 5, which would be, let's see, 36 times pi, divide that by 5, and you get 22.619, 22.619, so we'll call that 22.6, and the unit is in feet. So 22.6 feet. All right, let's do one more, and we'll call it a day. All right, given theta equals, let's say 527 degrees, and R equals 3 centimeters. What are we going to do here? Well, we've got to change this. This is 527 degrees, and we want to make it into radians, so we have to do pi over 180. So this is 527 degree, oh, the degrees will cancel, sorry. 527 pi over 180. All right, so our S is going to be equal, that arc length is going to equal 3 times 527 pi over 180. So what is that going to be? Well, that's 3 times 527. That's that times pi, and then divide all that by 180, and we would get 27.5936. So we'll call that 27.6, and that's in centimeters as an arc length. All right, so that is basic idea what we're doing. You need to be able to convert from degrees to radians, radians to degrees, and you need to be able to find unit circle values, and finally be able to find the length of an arc. I'm going to cover one more thing because I think they throw a few of these in here. Let's do the area of a circular sector. All right, area of a circular sector. Now, this one is, again, I'm going to give you a picture to give you an idea what it is. It's going to look similar to what we just did. We do this, and then from the center, I draw a central angle. Well, before we were looking at the length of this arc. Now what we're going to be looking at is instead the area of this cutout piece of pie. That's a circular sector. All right. And it's going to be based on these same measurements. We know R, we know our theta, and we're going to work with that. So our area here is going to equal 1/2 R squared theta. All right. So what is this going to look like? If I tell you, for example, if they want the area of the circular sector, let's say they give you theta equals pi over 6, and they give you a radius equal to 14 inches. Let's find the area. Well, area would equal 1/2 our R squared, so that's 14 squared, times our theta. And they gave it to us in radians, so we use pi over 6. And we can say this is, well, I would start with 14 squared on my calculator, do 14 squared times 0.5, and then times pi, and then divide by 6. And I would get 51.3126. So we would say 51.3, and remember this is an area, so this is in inches squared or square inches. All right, again, I think pretty straightforward. If they give you a degree measure, you translate it into radians again. We can only get measurements and things that rely on measurements like this area or that arc length that we talked about previously when we have our thetas in radian measure. So make sure that you do change them into radian measure. All right, that covers it, guys. Make sure you get the homework done for 6-1, and we'll discuss this tomorrow. Have a wonderful evening.